Hi, I'm Yishen, and I'm glad to share our work, SINC, Self-Supervised In-Context Learning for Visual Language Tasks. In-context learning is an interesting ability of large language models. This ability helps us to dynamically construct different predictors by providing different demonstrations in inputs. The pro of this method is that we can tackle tasks based on large language models without any fine-tuning. However, the con is that the language models we used here should be large enough. Prior works have observed that only large language models show this intriguing ability. The in-context ability have also been applied to the visual language domain, and prior works actually share many similar ideas. For example, they are often based on large language models that can do in-context learning themselves, and they aim to add some trainable modules to introduce visual information into these language models. However, manipulating large language models could still be challenging in many scenarios. Therefore, in this paper, we try to solve a general question. How can we enable in-context learning without relying on the intrinsic in-context ability of large language models? Before answering this general question, we would like to first investigate, why do we need large language models to do in-context learning? Our observation is that the in-context ability could be actually incidental, since typical language modeling is not intentionally designed for it. So this implies the efficiency of acquiring in-context ability could be low for prior works. That's why we need large enough models for in-context learning. Based on these observations, the core ideas of our methods are twofold. The first one is decouple. We aim to decouple the acquisition of in-context learning from conventional pre-training, while prior works typically consider these two things together. The second one is incentivize. We aim to incentivize the in-context ability through both architectural and data perspective. The figure below shows the simplified proposed framework. We introduce a meta model specifically to perform in-context learning, and the input is a series of features. And these features are extracted from the general pre-trained models. As you can note, the inputs are intentionally designed to be the form of in-context learning. During training, we specifically design self-supervised prompts to teach the meta model to do in-context learning, and after the training, the models could be directly used for tasks like VQA or visual entailment, etc. This framework first showed that we aim to decouple the typical pre-training and the acquisition of in-context ability. Also, with the designs of the self-supervised prompts, we aim to incentivize the acquisition of in-context learning. The design of self-supervised prompts are actually critical. The key point is that we need to make sure that the model can learn to leverage the information from both demonstration and the query data. For this purpose, we designed 3 different prompts that could jointly achieve this goal, and each type of the prompt helps the models learn different abilities. We also have other architectural designs for the complete framework. The experiment results show that our SINCs achieve state-of-the-art compared to previous gradient-based methods and also a strong in-context learning baseline. More importantly, we conduct diverse analysis for our framework to help us understand what are the critical elements for the emergence of in-context learning. We consider these results could further inspire the following works about in-context learning for visual language tasks. Thank you. If you are interested in our work, please refer to the paper for more details.